Okay, so integration using long division. So let's do first a kind of a simple one so that I can review with you guys how to do synthetic division as opposed to long division when possible. So here is our integration that we have to perform. And we notice we have a polynomial in the numerator, a polynomial in the denominator. The polynomial of the numerator has a degree higher than the polynomial in the denominator. Therefore, we know we're going to use division. And this divisor, what we're going to divide by here, is a linear polynomial. So we could use synthetic division. So to use synthetic division, first we need to make sure we have all the terms. So we have a cubic, a quadratic, a linear, and a constant. So we're good to go. And then we're going to extract kind of the coefficients and the constant. So we're forgetting about the variables. We just take the coefficients. So I need a 3, an 8, a negative 10, and a 15. And then in the box here, I'm going to look at what is it I'm using to divide. So x plus 4, but I want the 0 of that. I want the x, right? So I'm going to use a negative 4. So that's where that comes from here. We use the opposite of what we have here in the box. And now we're going to leave one blank line here. And we're going to bring the first one down because we need something to start with. So we put the 3. And then in that direction, we're going to multiply. And then when I'm going to go that direction, I'm going to add, okay? So this direction, I'm going to take 3 times negative 4 is negative 12. Write it on the line we left blank. And now those, I'm going to add them right in that direction. So we're adding that. So that would be a negative 4. And then we restart. So negative 4 times negative 4 is a positive 16. And then we're adding those, so that's 6. Multiply, so that would be negative 24. And then add those, and that will be a negative 9. Now that's your remainder, and then those will be your answer, right, plus the remainder. So the first one here next to the box, next to the remainder, it goes up by degree. So that's your constant, that's your linear term, that's your quadratic term. So the answer will be 3x squared minus 4x plus 6, and then minus 9 over, because it's a negative, what we divided by, right? So x plus 4. And this is what I'm going to integrate now. Don't forget your dx back there. So see, synthetic division is kind of nice and cool and quick, but only works if you're dividing by a linear term, right? Okay, so now I can integrate that quickly. Raise your power by 1, divide by that new power, so it'll be x cubed. And then here we're going to raise the power by 1 is a 2, then we divide by that 2, gives me a 2 for divided by 2, right? And then here I don't have an x, so now I'm going to have, I forgot my 6 there, didn't I? And then this one is going to be our natural log, right? So minus 9, and we have a natural log. This is not guaranteed to be positive, so we're going to need absolute value, x plus 4, close, and don't forget your plus c. And that will be our answer. See, that was very, very quick right there. Okay, you have that on your video, so if you need more time, you can pause, rewind, etc. But I'm going to keep going. And let's divide. Let's see. How about something like that? When I have a linear in the numerator and a linear in the denominator. So my question is, can I go ahead and do that? Sure, I can. And first of all, I want to notice, that I have a factor of 2 here that I could take out. So I'm going to actually go ahead and do that. And then it's x minus 5 divided by x minus 1, and then dx, right? Well, if you're doing your long division, or in that matter, we could do the synthetic division. So the coefficient here is a 1, and then the constant is a negative 5. And in the box here, remember, we're dividing by x minus 1, take the 0, that would be a positive 1, right? So that's what I put here. Bring the first one down. 1 times 1 is 1, write it down, add this direction, that's a negative 4, and so that's your remainder. So this will give me my 1/2 here, and then I want to integrate. So 1, no more x, minus my remainder over my divisor, right? X minus 1 and then dx. And that's nice and easy to integrate now, isn't it? So we have 1/2. Let's do that this way. This becomes an x minus 4. That's a natural log. I need the absolute value because this is not guaranteed to be positive. And then plus c back here. And in fact, I'm going to go ahead and distribute that 1/2. So that will be x over 2. Oh, I hope you can still see that. This direction a little bit. So we have x over 2. Sorry, I think I said plus 2. So I'm going to distribute that 1/2, and that becomes a negative 2 natural log absolute value of x minus 1 close plus c. If we wanted to, we could take that inside as an exponent, right? But this answer would be perfectly all right. But then I could also say that's the same thing as x over 2 minus the natural log of x minus 1 square it, right? By using the properties of exponents, I know I can do that. And now I don't need the absolute value anymore because this would now be guaranteed to be positive, right? Okay. So those were 2 more examples on division and how to do that. And let's look at the notes we had on our paper. Is there another one that was interesting, like what we had? So we need completing the square for that, and we need completing the square for that. So this will be it. Okay, so I think I'm going to include one more. Just so I can give you one more example here. I hope that's going to work out here. So we're going to have the integral of 2x cubed plus x squared minus 11x plus 20. And I want to divide all of that by x squared plus 2x minus 3. And don't forget your dx in the back for your differential. Now, we cannot do synthetic division here because this is not a linear polynomial we are dividing with, right? However, we can do division because this is a higher degree, so x cubed is higher degree than x squared. So we're going to have to do long division though. So let's get it going. So we're going to have 2x cubed plus x squared minus 11x plus 20. We don't need any placeholder because we have a cubic term, quadratic term, linear term, and constant. And then we're going to divide by x squared plus 2x minus 3. Alright, so we're saying, okay, on the side, what we're thinking is 2x cubed, right, the first term here, divided by this one. And then that simplifies to 2x, right? So I'm going to come up here and say, okay, I want a 2x. Now we're going to multiply. So I'm going to erase that. And so when I multiply, it will be 2x cubed. We always have to go back to what we had here, or we know we picked something wrong for up here, right? 2x times 2x will be 4x squared. 2x times negative 3 will be negative 6x. And now we need to remember that we have to subtract, right? So I'm going to change, so subtract, subtract, and subtract here will make that positive. So those cancel. A positive x squared minus 4x squared is negative 3x squared. Negative 11x plus 6x will be negative 5x. And we're going to bring the constant down. And we're going to do the whole process again, right? So we take the first one here, and we divide by the first one here. So the leading terms, right? And that will give me a negative 3. So that's what I'm going to put up here, minus 3. And I'm done with that, so I can erase it. And now I multiply. So negative 3x squared, negative 6x, and then positive 9. Now we have to subtract, right? So we change the sign. So minus becomes plus, and this one becomes a minus right there. And becomes just x, and then 20 minus 9 will be 11. And this is going to be my remainder, right? Because how do I know that? Because this degree right here is now lower than this degree, right? So I am done. This is smaller than that. So I'm done. So the answer will be, and that's what I'm going to integrate now, 2x minus 3, and then plus x plus 11 over what we divided by, right? So x squared plus 2x minus 3, and then the dx. Ooh, I think I picked a bad one. I think I picked a bad one, guys. Okay, let's look. So we want to integrate all of that. Well, those two, no problem. We can integrate very quickly. I'm actually going to do that. So that will be x squared minus 3x, right? This will be it. We are done with this one. Now, this will be x over x plus 11 over my divisor x squared plus 2x minus 3 and then dx. Now here we have a little bit more trouble, right? We're going to look and I'm going to think, can we factor that? And in fact we can, right? So how about I go ahead and do that? Let's factor that. So that will be x plus 3 and x minus 1, right? And when you're factoring now, we're going to have to use a method called partial fraction, and it's something that we're going to do next week probably. But let's just quickly have a preview of it then, since I put that problem in there and I didn't really mean to, but there it is. So if I want to break that into two different fractions, I cannot just say, oh, that's x over one of them and 11 over the other, right? That doesn't work this way. So what I'm going to do, and I'm going to erase my division here, and I'm going to have a thinking bubble where I'm going to be thinking and working. And so what I'm going to do is I'm going to say, okay, whatever that numerator is, x plus 11 over x plus 3 x minus 1 would be equal to some kind of numerator over x plus 3 plus some kind of numerator over x minus 1. So really what I'm doing here is I'm thinking through saying, okay, I have a common denominator here, right? It's all over that, x plus 11. But before, that could have been two different fractions with their own denominator, right? And then to combine here, I will do a times x minus 1, right? And then I will do b times x plus 3. And that will then be equivalent to what I have up here. So a times x minus 1 plus b times x plus 3. Here I'm just going through the process of doing an addition of two fractions, wanting a common denominator, right? And so that has to be equal to the numerator I have up here, right? So it has to be equal to x plus 11. And all of those, by the way, now are over their common denominator, right? Of x plus 3, x minus 1, x plus 3, x minus 1. Now, I don't really need the denominator because I want to figure out what a and b are so that I can break that into two fractions so that I can integrate. That's my goal, right? I want to break that into two fractions. So I'm going to kind of forget about the denominator since it's common, right? We're not going to worry about it. We're going to worry only about the top. Distribute your a here, so you have ax minus a, distribute your b, plus bx, and plus 3b, and that's going to be equal to x plus 11. Well, if this is the case, where are all my x terms? I have ax plus bx on that side, right? And I have only one x term on that side, so that will have to be equal to this x term, right? Combining like terms. That would mean that factor out your x. A plus b is going to be equal to that, which is, I'm writing it this way so you really see it, but will that not be the same thing as 1x? The coefficient here is 1, therefore that one has to be equal to a plus b. So that now we know that a plus b equals 1. So we know that already. Now let's look at the other things we have. So we had a negative a and a 3b. So minus a plus 3b. No variable here, so that has to be equal to my constant. So that has to be equal to 11. So I'm going to write that below here. Do you see where I'm going? Whoa, calculus is just beautiful. It puts all your math classes to work, doesn't it? It's just kind of really cool. Because what we're doing now is a system of equations. We're going to solve that system. And I'm going to solve it using elimination. So a minus a cancels. That will be 4b. And that will be 12 divided by 4. And now I know b is 3. And if I know b is 3, I can go back to this one up here. And if that's 3, then a will be equal to 1 minus 3, which is negative 2. Right? So what is that telling me? It tells me that I can break this fraction, this one, into two fractions where a is negative 2, will be over x plus 3, and b is 3, and it will be over x minus 1. So let's do that. So here I have, go back here, x squared minus 3x plus the integral, not of that anymore, but of my a over x plus 3, a being negative 2. So negative 2 over x plus 3. And I'm going to go ahead and write that like that already, or I can just do it this way. Plus 3, right, my b over my x minus 1, and then dx. And why was that what I wanted? Because see how those are now nice and cool. They're just natural log, and they're very quick to integrate. So we have x squared minus 3x. I have a negative 2 here, so negative 2 natural log of, oh, sorry, I need an absolute value here, right, because that's not guaranteed to be positive. X plus 3, and I'm running out of room, so I'm going to erase that here. And then this one will be plus 3 natural log absolute value of x minus 1, close, and then plus c. Ooh, wasn't that fun? I think it was. Alright, and we involved the solving system of equations from Algebra 1, way back way for you guys in middle school. Alright, I see you in class. Bye.